What you're going to learn about today is something we call simplifying variable expressions. If you remember from a few lessons ago, variable expressions are groups of terms, both numbers and variables, that together make a value. Here's a vocabulary. We have 4 words today. Our first word is terms. And the word terms refers to all the different pieces, all the parts of an expression. Now we're going to get a little bit more specific. Number 2, coefficient. The coefficient is the number part of a term that has a variable. So if we had the term 5x, the number 5 would be its coefficient. Next we have the word constant. A constant is a number that has no variable, which means its value never changes. Thus the word constant. And then finally, like terms. That means terms in an expression that are alike. Either that we are grouping terms that are constant or terms that have variables in them. And while this might be a little overwhelming and feel a little confusing because the words are new to you for the most part, I'm sure that by the time we get through our 5 examples, you will have a very, very clear understanding of what these words mean. Let's take a look at our first example. It says, identify the parts of this expression. Wow, take a look at this. We have 6h minus 14 plus 3h minus 14h plus 26. And as I've said in class, we have been accustomed, we have been trained to read this problem exactly as I just read it. But now that you are in pre-algebra, as I said, we need to start retraining your brains to see this not as just an expression, but as the individual terms. And here's what we have. We have a positive 6h. We have a negative 14. We have a positive 3h. Remember, the symbol belongs with the term that follows it. We have a negative 14h and a positive 26. So I am going to just very quickly jot those down here next to the word terms. So as you can see, it really just looks as though I'm rewriting the expression, but notice there are commas separated because I want you to see this as an expression that has 5 separate terms to it. Now what we have to go through is identify the like terms, which are the terms that can be combined. And remember, like terms mean either terms that have variables in them or terms that have constants. So first let's group the terms that have variables. We have 6h, we have positive 3h, and negative 14h. Separate from those, we have 2 constants, negative 14 and positive 26. Now we're going to look at our variables. So we're concentrating just over here. We have 1 variable, and that is the letter h. Since it's the same variable used multiple times, you only have to list it 1 time. Coefficients, so we're going to focus right here. Our coefficients are positive 6, positive 3, and positive 14. Notice they are the number part of this variable term. And then our constants are pardon me, negative 14 and positive 26. So now what we're going to do in our second example is take a pretty long expression and simplify it. When we simplify it, what we mean specifically is to identify the terms that are like, and then step by step combining them so that we will move from an expression that has 5 terms in it down to an expression that has only 2 terms. And the rule for writing an expression in pre-algebra, in case you forgot, is that the term or the terms that have variables have to come first and the constants are last. Let's identify our terms that have the variables. We have a positive 3z, we have a negative 19z, and we have a positive 7z. So I am going to put those in the next line of our work, grouped together. And then what we have left are our constants. We have a negative 18 and a positive 23. Now, a lot of people, a lot of students feel that, or are of the opinion that using these circles and underlining and then arrows before in the other lesson when we were using distributive property, that it's somehow babyish, but it's really not. These are good tools. And if you want to use different colors of pencils or pens, if that would help you, then I think that you should. It's important that you understand the math. So if this strategy resonates with you, then you should do this and not really worry what other people think, because the truth is, this will help nearly everybody. So now we're going to combine our terms. And remember, we can only combine the terms that are like. And what I'm going to do here, I'm not going to take the time to write it out, but I just want you to know my process. I am going to use the commutative property and the associative property of addition. Because when I see this positive 3z and this positive 7z, I know right away that they make a positive 10z. And I like that. And then we have a negative 19z. And we'll leave that there for now. Here what we have is a negative 18 and a positive 23. And you know the rules of combining integers. When we have signs that are different, we subtract the two numbers. So we end up with 5. And since the 23 is a higher number and it's positive, that 5 is positive. But we have just one more step. We're going to chip away at this positive 10z and the negative 19z. Again, same rules apply. We subtract the coefficients because one is a positive, one is a negative. Since 19 is the higher number, we are left with a negative 9z and a positive 5. So here you can see we have moved from 5 terms very systematically, very methodically, down to 2, negative 9z plus 5. We're going to do the same thing in our third example, but what we have in our third example is that we are adding in the distributive property. Rules of PEMDAS tell us we have to take care of our parentheses first. So I'm just going to bring down this 10y, and now let's take care of the distributive property. Here we have a negative 3. It's important to see that. So we're going to multiply negative 3 times positive 6, which gives us a negative 18. And now we go back to our negative 3, and we multiply that by our negative y, and that gives us a positive 3y. Now that we have taken care of the distributive property, we can identify our like terms and start to combine them. Here we see we have 2 terms that have variables. We have positive 10y and a positive 3y. So I'm going to write those here. And we can't forget this constant, our negative 18. Then when we combine these terms, we get positive 13y and a negative 18. And that's number 3. Wow, take a look at this. have here again, we have 5 terms. We have a negative 5w to the second power. We have positive 23. And take a look at this. We have an example of the distributive property, but one that you may not be used to yet. Remember when we first learned about integers, I told you that when we were subtracting a number, we weren't really subtracting. What we were doing was taking this minus sign, and this minus sign tells us that we have to use the opposite of the number that follows it. Here's what I mean. This negative 5w squared and this positive 23 are just going to come down because we're not doing anything with them yet. But here, let's talk about this piece. What we would read this as is negative 5w squared plus 23 squared minus the quantity 29 minus 4w squared plus 9. That's how we read it. This is how we work with it. We take this negative. This means what is the opposite of this piece. So what we're going to do is take this opposite sign and distribute it to every term within these parentheses. And the opposite of 29, of a positive 29, is a negative 29. The opposite of a negative 4w squared is a positive 4w squared. And the opposite of positive 9 is negative 9. It may look confusing, it's definitely a challenge, but if you draw your helper arrows and circle what you need to, and really take your time, I know that you will be successful. And remember, what is our next step? We identify and combine our like terms. We have 2 terms here that have a variable, and I included this second power for our variable just to show you that the process doesn't change. I'm going to group our like terms over here. We have a negative 5w squared and a positive 4w squared. And everything else in our expression is a constant. So I'm just going to add them in here. And now we're going to combine the terms. Here we have a negative 5 and a positive 4. You know that that gives us a negative 1. And then we add our variable and the exponent that belongs to it. And then we have a positive 23 and a negative 29. When you combine those terms, you end up with a negative 6. And then to that negative 6, we combine the negative 9, which gives us a negative 15. And we can stop right here exactly where we are with a negative 1w squared and a negative 15. But there, I want to show you one actually simpler way to write this. This negative 1, coefficient of a w. When the coefficient of a variable is either a 1 or a negative 1, you do not have to write the number. You can simplify this further. Negative 1 times w squared is a negative w squared, negative 15. And as you become more fluent in the pre-algebra, you will start to recognize this as having a coefficient of a negative 1. Either one that works best for you is the one that you should use. For now, it might be better to use negative 1 as a coefficient or positive 1 when that's the case, and then eventually you will move to this. But long story short, this very big expression has been boiled down to negative w squared minus 15. And we have one more example, and this time we have more of a real-life application to simplifying expressions. As I said in other videos and other lessons, Finding the area of figures is a very common task given to my students. Here we are deviating from that and we are finding the perimeter of this triangle. One thing that doesn't change is that we always start with the formula. To find the perimeter of a triangle, we simply add up both sides. So we show that as P equals A plus B plus C. And I did most of the work already. I'm calling this side A, so we have 3x plus the quantity 5x minus 4 plus the quantity 2x plus 5. Now the reason I wrote it in parentheses is I wanted to show you that each side was separate. And now what I do is I'm rewriting these side expressions without the parentheses. We have 3x, there's our A. Now this plus the quantity, just like in example 4 when we had the minus sign, meaning the opposite of every term in the parentheses, this plus sign means that every term in the parentheses is going to stay exactly as they are. So when we rid our expression of the two sets of parentheses, we are left with 3x plus 5x, then a negative 4, a positive 2x, and a positive 5. Then in the next line of my simplifying, what I did was, here I identified with a red circle the 3 terms that have a variable, and then I underlined in green the 2 constants because those can be combined. Here, these are all positive numbers, so we have a 3 plus a 5 plus a 2. That gives us 10x, and a negative 4 and a positive 5. When we combine them, give us plus 1. So the perimeter of this triangle, pardon me, is 10x plus 1.